Okay, for this video, we'll be constructing the Lewis structure for CH2CHCH2 with a negative. And before we start constructing this molecule, we should figure out how many bonds it should have. And we do that by using this equation. Number of bonds equals the demand minus the supply all over 2. Well, what is our demand? Our demand is to satisfy each atom to have a full outer shell or a noble gas configuration. We know hydrogen has a duet rule where it likes to be like helium. So hydrogen likes to have 2. So we have 2 here, but we have 2 hydrogens, so it'll be 4 because 2 plus 2 is 4. Carbon likes to have an outer shell of 8 to be like neon. It follows the octet rule, so 8. Let me make that smaller. 8. Hydrogen, once again, duet rule. We have 2 here, so 2 plus 2 is 4. And if we add all those up, that should be 34. So our demand is 34 minus our supply. Well, our supply is how many valence electrons each atom can actually contribute, and we find that out by looking at our periodic table. And we know carbon is found in group 14, so it contributes 4 valence. Hydrogen is in group 1, contributes 1 valence, but we have 2 here, so we'll say 2. Carbon 4, hydrogen 1, carbon 4, once again hydrogen 2, but keep in mind we have this negative charge, so we had to put another 1. We have to add another, because the electrons are negatively charged, so we're adding another electron. So we'll add all that up, and that should be 18. So let me clean that up. 34 minus 18, all divided by 2. And that should give us 8. Okay, what we have down here is our molecule. Our atoms already laid out. In between them, we have double-sided arrows. And they are all enclosed in brackets with our negative because our molecule is negatively charged. And what a good idea is before constructing our entire molecule is to first connect our hydrogens because we know they follow the duet rule. So we'll do that first. Now let's finish connecting our molecule. Okay, so we have 1, 2, 3, 4, 5, 6, 7 bonds, and we have 8 to give. So 8 minus 7 is 1. So we can either put this bond between this carbon or this carbon. Let's just choose this carbon first. Now we must finish off giving each atom an octet. So let's do that. This carbon needs an octet, and that should be it. So we see here we have 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 is our supply, so that checks out. But keep in mind, we still have to figure out our formal charges on these atoms. And what a good idea is to remember is if carbon has no lone pairs and is connected by 4 bonds, so 1, 2, 3, 4, we can simply say it's 0. So this carbon has a 0 formal charge. Let's look at this carbon. It has 1, 2, 3, 4. It does not have any lone pairs. It only has 4 bonds, so we can say it's 0. So let's look at this carbon. So carbon has 4 valence electrons minus our lone electrons, which is 1, 2, plus our number of bonds. We have 1, 2, 3, or 3 single. 4 minus 5 equals negative 1. So that carbon has a negative charge. Okay. Before I construct our resonance structure over here, I'm going to redraw this molecule the same because once I do this method called electron pushing, where we go from a negative towards a positive, we'll be breaking bonds and we'll be moving lone pairs, so it can get kind of messy. So I'm just going to redraw it so it's more clear. Okay, in this case, we do not have a positive, but we can still start at the negative. So this negative is on the carbon. And we can see here is we can move this lone pair of electrons and move them between this carbon. We cannot place them between the hydrogen carbon because that would violate the duet rule, so they have to go here. And anytime we are moving lone pairs, we're also moving this charge. So this charge is now on this carbon. Now look here, we have 2, 4, 6, 8, 10 electrons surrounding this carbon, and we cannot have that. So what we must do is now break a bond. So we'll break this double bond and place these electrons right down here. So let me do that. I'll make it nicer by adding actual pairs. So that double bond was broken and now we have a lone pair. Keep in mind the negative charge is still moving, so now it's on this carbon. Let me remove this lone pair and actually draw a bond so it actually looks correct. There we go. Now we must ask ourselves, which one of the two is the best? Is it this molecule or is it this molecule? And we find that out by using these rules. Octet is the best, least separation of charges, negative formal charge on most electronegative atom. But they go in order, so we must look at this rule first, meaning it overrides all three. So we can see here is each atom has an octet, obviously except for hydrogen because they have a duet. Don't even worry about that. Now, least separation of charges. Well, they each have a negative formal charge, so now we have to look at the third rule. Negative formal charge on most electronegative atom. They are both on the carbon, so what we can say here is they are equally contributing to the resonance hybrid. And the resonance hybrid is a combination of all the resonance structures we can make, and is what the molecule actually looks like. But if they ask for just one Lewis structure and not the resonance hybrid, you could just draw one of these and they'll both be correct. So that does it for this video. I hope to help, and thanks for watching.